Good morning friends, welcome to Relief Tutorials again. In the last sessions, we have discussed about distance, displacement, speed, average speed, velocity, average velocity, and the most importantly, acceleration. We have solved the corresponding numericals also. So now the topic is about how we can represent motion of any object by graph. The topic is about graphical representation of motion. Means the whole motion of a body is represented on graph. First of all, let us take some knowledge about the graph first of all. We know that this is x-axis and here is the y-axis. This is the point of intersection of both, that is origin. This is positive x side. This is x dash means negative x side. From origin the upward side is positive y and here is negative y means y dash. From origin the coordinates of this point is 0, 0. From origin the right hand side is positive x side. This is negative side. This is positive y. Here is the negative y. So this area which contains x coordinate positive and y coordinate positive. So here on this, in this region, all the coordinates are of having positive sign. This is first quadrant. Moving anti-clockwise, look at this region in which x coordinate is negative and y coordinate is positive. So here the coordinates are of sign negative, positive. This is second quadrant. Look at this region having x coordinate negative, y coordinate negative. So both the coordinates are negative, negative. And this is third quadrant. Here x is positive and y is negative. So here is positive, negative side. So this is fourth quadrant. Each and every quadrant also can be represented separately. For example, you are going to represent such type of numbers in which both the numbers x and y both are positive. So only you need to show what the positive quadrant only, means the first quadrant only. So you can draw the first quadrant like this. This is origin. Here is positive x and here is positive y. So first quadrant. Means what I want to say that it is not always necessary that you have to draw all the quadrants, means you have to draw the full coordinate plane. Not always. We know that this x and y, means this type of graphs are used to represent or to show the relation between two quantities x and y. Any characteristics can be represented on the graph. If those two characteristics, if both are positive, then you have to draw only first quadrant. If both are negative, then you have to draw only third quadrant. So correspondingly, that each and every quadrant can be represented separately. For example, I think you have seen during the cricket match, run over graph. Means run and over are the two quantities. See, for example, we are not able to see the whole match. We are going to the class, we are going to school, so we missed some part of the match. Then we reach at home, switch on the TV, and 35 overs already passed out of the 50 over match. 35 overs already passed. Then what was the story of over number 1 to over number 35? How can we know that? So the whole journey of over number 1 to over number 35, that can be represented on the graph. And I think you might have seen that many times the graph is displayed on your TV screen. That describes the whole journey, that in which over how many runs are taken, which over is maiden, in which over the maximum runs are taken, in which over the wicket was fall. Each and everything can be represented on that graph. So that graph is showing the relation between two things, run and over. Now run and over are the two quantities to represent on the graph. First thing, we know that both the quantities are positive. Out of these two, none of them is negative. Over cannot be negative, run cannot be negative. So both the things are positive. So both the quantities are positive. So we have to show them on the first quadrant only. So while drawing or while representing the run and over graph, you have to draw only first quadrant. Now which one, run and over, two things are here, just like x and y. So which one out of these two, which quantity should be represented on x-axis and which quantity should be represented on y-axis? Okay, so for that, first of all you decide that out of these two, run and over, which quantity is independent? Which quantity is independent? Remember, independent quantity is always represented on x-axis and the dependent one, dependent quantity represented on y-axis. Okay, so out of these two, I think over is independent and runs are dependent on the over. For example, the bowler is bowling and the batsman is just playing defensively or just playing safely. He is not taking run, so the ball is counted. Okay, so it doesn't matter whether you are taking the runs or not. The overs are going on. So over is independent. Okay, now runs are dependent on the over. If bowler is not bowling, if overs are not throwing by the bowler, okay, then how the runs can be there? If the bowler is not bowling, he is just taking the ball and ran away, then how can the runs can be there? So runs are dependent on the over. Okay, whether you are taking the runs or not, overs are going on. Okay, so over is independent and runs are dependent. So over is represented on x-axis and runs are dependent, so they are represented on y-axis. So you can write like this, here is run and here is over. So now this graph is called as run versus over graph. What to speak? Run versus over graph. The y-axis quantity should be spoken first or written first. Versus, the symbol of versus is like this. Look at this. Runs versus over graph. Means the name of the graph is always like this, y versus x graph. Means the quantity on y-axis means dependent quantity first. See, this arrow shows the dependence. That y depends on x. Okay, so here run depends on over. So the graph, how to speak? Run versus over graph. Is that clear? This way. See, it all depends on which two quantities are representing. For example, if I ask you, what about the distance versus time graph? What about the distance versus time graph? Okay, so distance and time. Now we know that distance can never be negative. It can be positive. It is always positive if it is not 0. Time is always positive. So both the quantities again are what? Positive. So I think the first quadrant is enough for us. Let us say this is the first quadrant. Okay. So here is the origin. Now out of these two, distance and time, which one is dependent and which one is independent? So obviously time is always independent. Time does not depend on anything. So time represents on x-axis and distance represents on y-axis. Is that clear? Position versus time graph, both are the same thing. In place of distance, sometimes the word position also can be used. Same thing, distance or position, doesn't matter. So in place of distance, you can write sometimes what? Position of the body versus time graph. Let us take one example to represent that. See, okay, the number of things we have discussed. In our chapter, in our syllabus, we have to discuss two types of graphs. Distance or position versus time graph. First type of graph this is. Second, velocity versus time graph. Two types of graphs we are going to discuss. Let us start with the first type, distance versus time graph, or we can say position versus time graph. First type of graph. Let us take one example to represent this, and so we can understand the whole concept. Consider one of the particle here is the pole, or one of the pole is here, and here is one of the car. C for car. This is the pole, and here you are standing at the pole, means you are using pole as a reference point to describe the position of car. So car itself is at the pole only, and you are also here, you are taking the observation. Now from here the car starts to move. So initially the car is stationary here at the pole. Okay, so this is the observation. Let us say at 0 second means when you are just starting the observation, the car is stationary. So what is the distance of car from the pole? I think is 0 meter. So this is the very initial condition you have described, that in the very beginning of the journey, the car is at the reference point. Means you are here and you are taking the observation. You yourself or the pole is the reference point, and in the very beginning at 0 second, the distance of car from reference point is 0 meter. This is time, and this describes the position, or we can say distance of the particle from reference. After 2 seconds the car is here. After 2 seconds the car is here. So after 2 seconds, let us say the distance of car from reference point is 5 meter. One more 2 seconds passed, 4 seconds total time 4 seconds. After 4 seconds the car is here, moving faster, and it is 12 meter away from reference point. See, here you are describing position. Position is always described with reference to reference point. So from reference point, first of all the position is 0, then it is 5, then it is 12. One more 2 seconds passed, and the car is here only at 14 meter distance only, moving slowly during these last 2 seconds. So if you don't see the readings, then also you can see that the car is not moving with the uniform speed, because it is moving sometimes moderate speed, faster speed, and the very slower one. So that we know from the readings only. If you see the reading, see the time intervals each of 2 seconds. Look at this, 0 to 2, 2 to 4, 4 to 6. So we have kept the time interval same, but look at the distance traveled in first 2 seconds is 5 meter, in another 2 seconds is 7 meter, and then only 2 meter. So distance traveled in the equal time interval is not same. So the type of motion is non-uniform motion. Okay, that is the observation, but now we want to represent this on the graph. So how we can draw the graph? Can I draw like this? This is position, or we can say distance. Here is time. Okay, so position versus time graph. Now time 0 to 4 6, 0 to 4 6, and here is the distance as 0 5 10 to 40. So we can have the scale of 5. So 5, 10 and 15. First observation is 0 0. So here is 0 0. Then it is time 2 and position 5. So time 2 and position 5. So I think the point is here. Then 4 12. So it is 4 12. And then 6 14. Let us say here. Now if you join the points like this, look at the figure. So I think the graph is, see, this is the line of graph, and the line of graph is irregular in shape. This suggests you what? This suggests you non-uniform motion. Just for the sake of understanding, consider the first reading is 0 0. Okay, one example is over. Second example 2 5. Okay, then if it is 4 10, let us say the car is here at 10 meter, and then it is 15. If I say if, so now the new example is what? 0 0 2 5 4 10 6 15. Forget this for some time. So 0 0 2 5 4 10 and 6 15. So if you join the graph, it will be the straight line. So that represents what? That straight line represents what? Uniform motion. Uniform motion means what? The particle is traveling equal distances in the equal interval of time. So two things we have decided. First of all, see what we want to understand and what we want to take care of, that by just looking at the graph, we have to find out the type of motion. If I say like this again, that if let us say the graph of one of the object is like this, then what do you understand from this type of graph? It is distance versus time. S means distance, T for time. So distance versus time graph, and the graph is like this. So it is what? It is called as, the type of motion is uniform motion. Okay, and look at this. The graph starts from what? The graph starts from origin. The graph starts from origin means what? The particle starts moving from reference point only. Let's take one more example. Consider here is the reference point. Means you are standing here. The car, one of the car is here, stationary, not moving. The car is here, already at 5 meter distance away. Now the car starts to move. So what should be the first reading? So at 0 second, this is time, and here we are going to write the position. So at 0 second, the car already having 5 meter distance from origin. Now car starts to move in this direction. So let us say after 2 seconds, it is 10 meter away. After 4 seconds, it is 15 meter away. and after 6 seconds it is 20 meter away. We can see from the readings only that in 2 seconds 5 meter distance, another 2 seconds 5 meter distance, another 2 seconds 5 meter distance. So the particle is moving with the uniform motion. And how should be the graph of this? This is distance and here is time. 0, 2, 4, 6. Here is 5, 10, 15 and 20. So the first point is 0, 5. X-axis 0, y-axis 5. So the point should be here on y-axis. Then second point is 2, 10. So 2, 10, the point should be here. Then 4, 15. So it is 4 and 15, the point should be here. And then 6, 20, the point should be here. So if you join again, it is straight line. It is straight line, but the graph is not starting from origin. Here is straight line, but the graph is starting from the point on the y-axis. Look at the graph. So it indicates, yes, the type of motion is uniform motion, correct? Okay, uniform motion, but the particle is not starting its motion from reference point. It is already 5 meters away from the reference point. So that can be known with the help of graph. And most importantly, what can we know from the graph? Look at this. Here the observations of 0 second, 2 second, 4 second and 6 second. Do you have the observation that where is the particle at 1 second? You didn't take the observation, but that can be known with the help of graph. Look at 1 second is here. So at 1 second the position of particle can be known with the help of graph. At 1 second the particle should be at 7.5 meters away from the origin. What is the position of particle at 3 seconds? You didn't take the observation. You don't have the observation in your list. But from the graph, you can know the position of the particle at any time. Not only on 3 seconds, not only on 1 second. You can have it at 3.5 seconds, 4.6 seconds, whatever it may be. You just have to draw the graph precisely, and you can use the graph in many ways. Is that clear? So many things are there. Okay. For example, if I ask you that again, what can you say about the type of motion if the distance versus time graph is like this? Irregular graph. So irregular graph, so you can say it is what, nothing but the non-uniform motion. It is non-uniform motion. If I say the graph is like this, distance versus time, and the graph moves like this. So first of all, it is a straight line. So if it is a straight line, the type of motion is always uniform motion, and also the graph is not starting from origin, means the particle starting its motion somewhat distance away from reference point. It is moving away. It's going away from the reference point. Okay, if I say the graph is like this, number of types of graphs we can see. If I say the graph is like this, so look at this. What does it indicate? First of all, the point at the first point is very far away. So it means what? The particle initially at very far distance away from reference point, and look at the graph is moving reverse, means it is coming towards the reference point. So you can consider the example of this graph is like this, that consider here is the reference point and here is the car initially, and now car coming towards what? Coming towards reference point. So the distance of car from reference point decreases. So that type of motion represented by such type of reverse flowing graph. Is that clear? One more thing, and not more, but the most important thing we can know from the graph, from the distance versus time graph. See, consider, let me draw the perfect graph for that. 0, 2, 4, 6, 5, 10, 15, 20. This is distance in terms of meter, and here is time in terms of second. And let us say this is the graph. The straight line one. Okay. In mathematically, not physically. In mathematics, we can find slope of the graph. Slope means how tilted the line is, or how slopey the line is. Slope itself says slope means what? The tilted means what? How slopey. Look at this. This is the slope. This by this much amount, it is slopey. It is not horizontal. It is not vertical. It's slopey. ઢાળવાળો રસ્તો છે. ઢાળ છે. So this is what the slope like this. Now how, by what amount the line is tilted, that can be known by some formula. So listen to me. To find the slope of this graph, first of all you have to decide any 2 points of this line of graph. You decide 2 points on the graph. Consider these are the points 1, 2, 3, 4, and origin itself can be found. You can take any other point also from this part also. So first of all, to find the slope, how to find the slope? Okay, so to find the slope, you first of all decide any 2 points of the graph. Let us consider I am deciding these 2 points. This is point A and here is point B. I am deciding these 2 points. Any 2 points you can select. Okay. Now corresponding to these points, what are the x-axis, x coordinates and y coordinates? This is the first point. So the first x coordinate is 2. Okay. And corresponding y coordinate is 5. For the second point, the x coordinate is 6, let us say. Yes. And it is y coordinate is 15. So this is point number 1, this is point number 2. So this is called as x1, this is called as x2, this is y1, and here is y2. Okay, so what is x1? 2, x2, x1 2, y1 5, x2 6, y2 15. So we have a formula of slope of graph is equals to y2 minus y1 upon x2 minus x1. This is the formula to find the slope. If you anyhow remember this formula, you can find the slope of any graph. So y2 minus y1, what is y2? 15. So it's 15 minus y1 is 5 upon x2. x2 is 6 minus x1 is 2. So 15 minus 5 is 10. 10 upon 6 minus 2 is 4. Okay. So it's 2. 2s are and 2 5s are. So 5 upon 2, that is 2.5. This is the mathematical representation. Now if you think physics wise, let us find the slope again of this graph. The formula for the slope remains same, y2 minus y1 upon x2 minus x1, x2 minus x1. But here in place of y we have s, and in place of x we have t here. Okay, so can I say, let me rub this. In place of this is what? t1, t2, and here should be what? s1 and s2. So slope formula is s2 minus s1 upon t2 minus t1, and therefore the slope is, look at this, what do you mean by this s2 minus s1? s2 minus s1 means the distance traveled during this time interval. Okay, so it's one type of distance, and upon t2 minus t1 means this time interval. So it's nothing but the distance upon time. Indirectly I am writing here just for the sake of understanding. indirectly it is nothing but the distance upon time, and distance upon time means speed here. So if we have the distance versus time graph and you want to find the speed of this particle, then you can find the slope. So in the distance versus time graph, slope represents speed. So slope is equals to S2 minus S1. So what is S2? 15, S1 is 5. So 15 minus 5 upon 6 minus 2. That is the same thing. So 15 minus 5 is 10. 6 minus 2 is 4. So it is nothing but the 2.5. Okay. But it says speed only. So distance upon time. So here is what? Meter per second. So 2.5 meter per second. So with the help of slope, we can find the speed of the moving particle in the distance versus time graph. Is that clear? Now if I say, consider this is the distance versus time graph. This is the line of graph of one of the moving particle. Okay, and this is line of graph of another moving particle. So two motions we are describing in the same graph paper. First of all, look at this graph A. Is it a straight line? Yes. Is it from origin? Yes. So we can say that this particle starting its journey from reference point and moving with the uniform speed because it is a straight line. Second graph. Is it a straight line? Yes. It is starting from journey from the reference point. Yes. And both are moving from this. So can we assume the condition like this, that here is a reference point, for example. So car A is here and car B is also at the same point. Okay. Both start its journey from the same time, same place, from the reference point only. But look at the slope. This is less slopey and here is more slope. Look at the intensity of slope. See, this pen is having no slope. Look at this pen. It's a horizontal, no slope. As you start to tilt it like this, what does it mean? The slope increases, slope increases, slope increases, slope increases. So as you move towards y-axis, slope increases. So here, the graph A having less means less slopey and B is more slopey, and in the distance versus time graph, slope represents speed. So which one is moving faster? Out of these two, which one? If someone asks you which particle is moving faster, so you can easily say that because the slope of this line B is more, B is traveling with the faster speed. So more slope, more speed. Less slope, less speed. Is that clear? Now if I say the particle having graph like this. So we know that this straight line means what? Uniform motion, and the particle starting its journey somewhat away from reference point. Now look at the slope like this. Now if the graph is exactly like this, means less slopey. So this is A and here is B. So both A and B starts its journey away from reference point and both moving with the different speed. A is moving faster, B is moving slower because less slope. What do you say about this graph? It is exactly horizontal. Now exactly horizontal means no slope, and no slope means no speed. No speed means zero speed, and zero speed means particle is stationary. So one more thing we found, that if the graph is exactly horizontal, if the graph of one of the particle is exactly horizontal, horizontal means it is parallel to x-axis. So if the graph is parallel to x-axis, then the particle is stationary. Then the particle is stationary. Is that clear? So if I say the graph is like this, already we discussed, it means what? The particle is coming towards the reference point. The particle is coming like this. If I say this is the reference point, you are here. If the particle is here, it is coming towards you, then the graph goes downwards. If it goes away from here, the graph like this. If it remains here, the graph is horizontal. So, conclusion of the whole discussion. Uses of S versus T graph. First, we can find position of a moving particle at any time. As we have discussed, that if you have this type of graph, you have the readings of 0 second, 2 second, 4 second and 6 second. You don't have the readings of 1 second, 3 second and etc. Then also you can find with the help of these graphs. Second point to be noted is, if the graph is straight line, okay, so if the distance versus time is straight line from origin, the type of graph and type of motion, the type of graph is straight line from origin, indicates you what? Indicates the type of motion is uniform motion, and uniform motion means constant speed. The speed remains constant speed, and here the graph starts from origin, means the particle starts its journey from reference point. Just by looking at the graph, you have to find out these things. Third, if I say, if the graph of one of the moving particle is like this, then again what type of graph this is? The graph is straight line. The graph is straight line away from origin. The graph is straight line away from origin, indicates you what? Indicates the type of motion is uniform motion, because it is a straight line, but the particle starts its journey away from reference point. Fourth one, if the graph is irregular, okay, so the shape of graph is irregular, that indicates the type of motion is non-uniform motion. Okay. Fifth one, if the graph of particle is horizontal, or we can say this graph is parallel to time axis, means x-axis. This graph, this is time, no? This is time and here is distance. And everyone we have tried this, S versus T. So if the graph is parallel to time axis, indicates you the particle is stationary, not moving. And the last and the most important use is, we can find speed by finding slope. To find slope, I have told you to find slope, you have to decide 2 points of the graph. So we can say speed into bracket slope is equals to y2 minus y1 upon x2 minus x1. Means you need 2 points of the graph. That also can be said s2 minus s1 upon t2 minus t1. Is that clear? So this is all about distance versus time graph and its uses. In the next lecture, we will discuss about velocity versus time graph and their uses. Till then, keep practicing. Best of luck.